We are back with our additive manufacturing course. I am Rauf Tailony. We're continuing today on the additive manufacturing materials. We will continue on what we started in the previous lecture. We mentioned before the materials that we recommend and we use for the SLA 3D printing technology. And today we will talk about the dental and medical SLA resins that are used to print parts related to dental and medical applications. The first material that we have is a material called Class 1 biocompatible resin. This resin can be used to make customized medical equipments like the surgical guides, and the parts that we print using this resin usually is steam sterilized using an autoclave so that it can have a direct use in the operating room. We can see here on the right some of the parts that are printed using the SLA 3D printing technology using the Class 1 biocompatible resin. The Class 1 biocompatible resin having ups and downs similar to any material that you're going to use in 3D printing. The good sides for this material is that it can have high precision when printed. So with addition to the high precision, you have smooth finish as well. It will have a smooth touch on the surface. The bad sides of it have a moderate wear and fracture resistance. So it will not give you a good job if your application involves forces, repetitive forces that can cause wear, or impact forces that can cause fracture. The next material is the Class 2 biocompatible resin. This resin is engineered so that it can handle long-term orthodontic applications. So Class 2, or it's known as Class 2A, it's a biocompatible resin. It can be in contact with the human body with no problems for up to a year. So before this material start to break down, and before that moment, it's still biocompatible. The body will not reject it, because when you have a certain part that have in contact with the human body or human skin, you want to make sure that the human skin or human body doesn't fight back this material as a foreign material. So this material, Class 2A biocompatible resin, can do that job for you, but it have a limitation that after 1 year it will be degraded. You can imagine if somebody having a severe broken arm, then you want to give the bones the chance to build and go back to its original state. Then you can give a kind of supporting material using Class 2A until the bone is in place. Then eventually you want this material to dissolve, so it can be a good application or a good choice for that kind of application. These kind of resins, they have high resistance to fracture and high resistance to wear, so it can be a really good decision so that if you want to produce custom hard splints or retainers. The good sides of this material is that it have high accuracy, high resistance to fracture and wear. The downsides of it have high cost. So it's going to be costly. Of course, you can imagine a material that's being used. It needs FDA approval and make sure that it's not against the health of the human body, and all materials are highly engineered with high details. So this material will be a costly choice to get. So if we want to compare Class 1 versus Class 2-1 biocompatibility, so the Class 1 biocompatibility regulations, they refer usually to materials that are allowed to be used for the following application. First, you can use Class 1 material for non-invasive devices that need to have a contact with the intact skin, and appliances for transient use, or you need to do it for a short-term use, either for oral or ear canal or in nasal cavities. And it can be used as well for reusable surgical instruments. For the Class 2, the application where you can use the Class 2 is either for devices that need to contact with the body fluids or open wounds, and can be used as well for devices that used to remove substances either to or from the human body. As well, you can use it for applications that involve invasive short-term devices like the invasive surgical elements, and as well you can use it for long-term implantable devices placed in teeth. The next resin that we'll talk about is the castable SLA resins. These are usually used for jewelry making because this material enables the printed parts to have sharp details and smooth finishes, so they can burn out cleanly without leaving any kind of residue after you burn it out. The castable resin give you the opportunity to do production of parts directly from the digital design so that you can cast through a single 3D printed part. They are suiting very well for jewelry and other small and intricate components. So this part here, some kind of early stage 3D printed supported part, kind of flipped ring with the supported materials on it, still not post-processed. This material is still not going under post-processing yet, so it can be a good solution for these kinds of applications to go with the castable SLA resins. The good sides of this resin that it have low ash content after burnout. It is measured to be less than 0.02%. It can give you fine features and high details. The bad sides of it that it have low impact resistance and low wear resistance. It needs a lot of post-processing to make sure you're getting the best results, especially if you're going with jewelry making. So you want to make sure that the part that you're producing as a final shape is aesthetic and visually pleasant. So for the SLA materials, we have a kind of summary for the general rules to follow. Firstly, you need to choose standard resin for prototypes that have smooth injection molding like surface finish, and you can use it for for functional prototypes. You can go with the tough resin. If you care too much in your design about the stiffness, you can go with durable resin for the parts that need higher impact resistance, or you can or if you are having moving parts, and you can go with ceramic reinforced resins if your parts need to have fine features. Regarding the rubber-like resin, you can produce parts that have low hardness and high flexibility, but you can't do any kind of high performance similar to the true rubber. Giving you low hardness, high flexibility, but it's not 100% similar to rubber. Still have its own downsides, as we discussed before. If you want to go with the class 1 biocompatible resins, then they are good. If you want to do external contact with human body, class 2 biocompatible resins, they can go for short-term invasive devices. For the castable resins, then they leave only very little residue and ash content after burnout that is less than 0.02%. That's used for jewelry related applications. Let's go with an overview for the SLA materials and resins that we discussed through our previous lecture and current lecture in terms of the resin type, the description, and the application. So we discussed before the standard resin. Application for this resin can go with the ideal, it could go as ideal choice for high detailed prototypes or models that are not going to be functional. The description of this material: it is used for general printing. It can offer high detail surface finishes with resolution less than 25 microns. These resins, they don't have any special material properties, and they are considered as brittle and even more brittle than the standard FDM material. For the engineering resins, they are applied for tough applications, flexible and high temperature applications. So the SLA resins manufacturers, they are trying to do simulation for the common engineering plastics, offering ABS or the polypropylene like flexible and high temperature resins. These resins can give you superior engineering properties without sacrificing your print quality, but it will give you a higher cost in order to get this material as well. Dental resins that we discussed briefly before, we discussed a couple of minutes ago. These dental resins go for dental applications, for general orthodontic applications, and general purposes resins or custom resins are commonly employed. Class 1 and Class 2 biocompatible resins allow for use of SLA technology now so that you can create surgical guides. These resins are considered highly precise and durable enough to be sterilized via autoclaving before you do your surgical use. For the castable resins, their applications are jewelry, fine detail models, and investment casting applications. These resins, as we mentioned, are having the property of fine detail and delicate feature printing. So they can be designed to allow direct investment casting. They can give you very small details and minimum feature size of 0.2 millimeters. If it's properly cured, then the resin burnout will have a little up to no ash or residue, which is a good side for this material. So moving from SLA to the SLS materials, we have a material called PA12. The properties for this material, in terms of mechanical properties, they are similar to the injection molded polyamide. They have good dimensional stability, good wear resistance, and high chemical resistance. The next material is the PEBA, known as TPA. The properties for this material is considered rubber-like, strong but flexible material. Next material is the alumide. It's aluminum filled with polyamide. The properties for this material that have high stiffness and good post-processing abilities. Materials printed through the SLS 3D printing technology with the alumide material. The 3D part will look something like this in its final form. We can go with the carbon filled polyamide as well. It have a high stiffness and a high strength. You can go with glass filled polyamide. The properties for this material is high stiffness and high wear resistance. So the PA11 giving you high impact resistance and high elongation at break. It's considered eco-friendly or environmentally friendly material. For the PEEK material, PEEK, it's excellent for mechanical properties. It can give you high temperature resistance. It have a possibility to be biocompatible and sterilizable. For the material jetting, the materials that are considered as choices to go through if you want to go with the material jetting 3D printing, we have here the material type, description, and application. So you can go with the standard material considered as rigid, opaque. The applications for this material can go with any application that needs high detail, non-functional prototypes, and parts that needs to have a very smooth surface. This material, the description of it is considered rigid. It is normally opaque in terms of color and transparency. It is available in white, black, gray, and blue. It's considered, most cases people consider it as a polyethylene. It's like trying to mimic or stimulate the polyethylene properties and visual representation. It's considered brittle compared to the other printing processes. Next material is, this is an example of the standard opaque resin used for material jetting. You can see here the engine body is being printed by that material for representation purposes. Next material is a transparent material. It can be used for clear prototypes and models applications. It's considered similar in properties to the standard, but it can be post-processed up to 100% transparent. This is a part that's printed through the material jetting 3D printing technology with the transparent material. It can be very handy for representation purposes and educational applications. There's an ABS-like material. Applications for this material are components that require to simulate the ABS. Parts are considered brittle and more brittle than the FDM or injection molded parts. The description of this material is considered durable digital blend of materials. It have higher temperature range and strength. It allow for good flexibility in features. It needs a minimum thickness on all walls to be 0.85 of a millimeter. These are materials printed through the material jetting 3D printing technology with the ABS-like material. You can see usually ABS and ABS-like materials, they always give you this plasticky feeling and plasticky appearance to it. So that's something to keep in mind based on your application. Polypropylene-like material. Applications for this material are components that need to simulate the PP material, and the parts are considered more brittle than the injection molded parts. So the polypropylene mimic material and considered as excellent for flex and snap features. Flexible material application for that is that can be used if you are designing for testing and design validation of gasket seals, over molds and buttons. They can be used in parallel with the rigid parts for multi-material design. The description of this material is a rubber mimic material. The blend of it can be done in a way so that it will have a custom durometer and ranging from very flexible to fully rigid material, same as the rubber. The materials focus on mimicking the feel and flex of the rubber are not a good solution for mimicking the elongation or the stretch. But you still can mimic the rigidity and flexibility for the rubber materials that are in the market. High temperature materials, they are good for applications with temperature of up to 90 degrees in operation. They are good for testing application like the hot air flow or hot water flow in pipes and faucets. It's considered a high temperature material that is compared to the ABS. The material requires the thermal post-processing so that it will achieve the maximum thermal resistance. The castable material can be used for dental, jewelry, and general custom cast part manufacturing. The description of it is highly accurate material, can be developed to produce parts with very deep and fine details, especially for investment casting. It can give you up to 100% near burnout. Biocompatible materials. These biocompatible materials can be used for dental and medical applications, of course. They are designed to be sterilized and offer short-term biocompatibility. In terms of the metal printing materials, if you go with any kind of technologies to print the metals in a 3D printed form, then you can go with the aluminum, known as ALSI10MG, aluminum silicon magnesium mix. So it can be used for applications in aerospace and automotive production parts. The description of this material, it is a casting alloy having good strength and hardness. It is used for it can be used because it have a good combination of mechanical and thermal properties, especially if you care about the low specific weight in your application. This is a part that's printed with the aluminum material that's mentioned previously. You can see how is the quality of the part overall. The next material is the Maraging steel, which is considered as 18 MAR 300 over 1.2709. It can be used for application of injection molding tools for series production and other mechanical parts. It's considered martensitic hardening steel with a good toughness and a good tensile strength and a low warping properties. It can be easily machined, hardened, and welded. It have a it will allow to be formed easily for different applications. This is a part used with the said material. Next material is the cobalt chrome, known in coding as UNS-R31538/ASTM F75. It can be used for applications of aerospace and medical implants and production parts as well. It's considered a super alloy with excellent wear and corrosion resistance. It have very good mechanical properties if your application involve high operating temperature. It have wear resistance, corrosion resistance, biocompatibility, which make it very good for surgical implants and high wear applications. This is a part used with that material, a part that is printed using this technology, using the cobalt chrome material. Next one is the stainless steel 316L. It can be used as well for aerospace and medical surgical tools, applications and production parts. It's considered an authentic chromium nickel alloy with a high resistance and high wear and high strength resistance. It's very good with high temperatures operations, and it can keep its strength during these high temperatures. It have formability property and weldability. It can be used for corrosion resistance applications, including pitting corrosion and chloride involved environments. This is a part that's printed using the technology mentioned and the material detailed. Next one is the stainless steel 15-5PH. It's used for production parts of various industries. It's considered, as a description of it, it's considered a precipitation hardened stainless steel with excellent strength, toughness and hardness. It's very good combination for strength and fabricability. It can be easily heat treated, and it can be corrosion resistance, which make it popular to be used for many industries. For the stainless steel 17-4PH, production parts for various industries is considered the application, and similar to the stainless steel mentioned before, it can give you good strength and fabricability. It can be heat treated, and it gives you corrosion resistance, which make it a good choice for a lot of industries. This is a part printed with that material. The next one, which is a famous one in the industry, the titanium, especially in medical applications and aerospace and automotive application. It is the titanium Ti6AL4V over grade 5. It is an excellent mechanical material that have corrosion resistance and low specific weight. It's used mostly because it have excellent strength to weight ratio. It is fabricable, and it can be heat treated as well. This is a part that is printed using that material. The next one is the titanium of titanium Ti6AL4V, same code in the first, over grade 23 instead of grade 5. Can be used for medical implants, production parts. It's considered an excellent mechanical material that have corrosion resistance, low specific weight. The strength to weight ratio is high, fabricability is valid, and it is a biocompatible material. It's used a lot in the medical applications. It can give you an improved ductility and fatigue strength, which make it very, very good choice for a lot of medical applications that are happening today. This is a part that's printed using that material and metal printing technology. The next one is the nickel alloy Inconel 718 over UNS and 07718. It is used for aerospace applications, especially in high temperature turbine components. Even can be used for aerospace production parts in general. It is considered a super alloy with the excellent yield properties, tensile and creep rupture strength at high temperatures. It can be used for high strength applications with extreme environment. It have a good weldability compared to other nickel based super alloys. This is a part printed with that material, an exhaust passage that goes to the engine head. For the nickel alloy, Inconel 625, UNS and 06625, again same as the previous material, aerospace for high temperature turbine components. It's a super alloy with excellent strength, toughness and at high temperatures. For the nickel alloy of UNS and 0602 over Hastelloy X, the application is production parts in severe thermal conditions and high risk of oxidation, like the combustion chambers, burners, and support in industrial furnaces. It is considered super alloy with exceptional combination of high temperature strength, fabricability, and oxidation resistance. It can be used for high strength applications in a very extreme environments. It is considered resistant to stress, corrosion, cracking, especially in the petrochemical environments. It is excellent for forming and welding characteristics. For the binder jetting material, we can go with the full color sandstone. The applications are full color non-functional models, very brittle, and description can be used for printing realistic high definition full color concept models and prototypes. This is an example of that material. You can go with the silica sand. It's considered very high thermal resistant material, excellent for sand casting applications. A description for that material: it's used for wide range of applications like creation molds and cores of industrial castings. Silica sand can be used for 3D printing without changes at the foundry, which is considered as a benefit. For the stainless steel, bronze infiltrated, applied because it have good mechanical properties, it can be machined at 10% internal porosity. It's considered stainless steel infiltrated with bronze, considered as a material composed of 60% stainless steel, 40% bronze infiltrant. So this material have a lower yield strength, which giving it machinability and polishability properties. This is a material produced and printed with. This is a part printed with that material and the binder jetting technology. Stainless steel that is sintered, it is having good mechanical properties, high corrosion resistance, 3% internal porosity. It can be easily machined and polished. It gives you high tensile strength and high temperature resistance. Inconel alloy that is sintered, it is having good mechanical properties, good temperature resistance, high chemical resistance. This material is considered a nickel chromium based superalloy, giving you excellent mechanical properties, especially in the extremely high and low temperature. It can give you high resistance to oxidation at elevated temperature up to 1050 degrees Celsius. The tungsten carbide sintered, it's considered a material that's having a very high hardness. It can be used for production applications. It's considered one of the hardest carbides, that having melting point of 2770 degrees Celsius. It is mainly used for production of high wear resistance abrasives, carbide cutting tools like knives, drills, and circular saws, and can be used for milling and turning tools by the metalworking, woodworking, mining, petroleum, and construction industries. Snap fit application materials. So we have here the process that we go through and the description of the process. So if you want to do snap fits with the FDM 3D printing technology, then it can be cheap and effective way of manufacturing a snap fit, but will give you lower accuracy than other printing methods. If you want to print with FDM, it's highly recommended to use strain resistant material like the ABS, nylon, and TPU. If you want to go with the SLA 3D printing to do your snap fit, then the SLA resins can easily be used for snap fits, but remember that they are brittle, and if you have a repeated use for your snap fit, then it will break after a while. You can go with durable SLA resin with the snap fit applications. For the SLS 3D printing technology, it can give you snap fit prototypes for sure, and it can easily handle opening and closing the snap fit many times. For maximum tear resistance, you need to use the SLS nylon material. If you want to go with material jetting, it gives you good strength and good elasticity, high resolution details. You can go with a durable resin and digital ABS for that kind of application because they have toughness and flexibility.